And the first one probably makes sense. We talked about that. But notice the positioning. This is the converse. We talked about converse, inverse, contrapositive. And in this one, before I said if it is a right triangle with C as the hypotenuse, then this exists. So now we've taken the hypothesis and made it the conclusion, and taken the conclusion, made it the hypothesis. That's why this is the converse. So in the first one, if the measure of angle C equals 90, then triangle ABC there we go. And we know that's going to be a right triangle. Okay, then you found if the C squared was less than 90, then the measure of angle C, and when I say the measure of angle C, that is assuming that C is across from the longest side, okay? So that's what that measure of angle C is talking about, being across from the largest side, which we identified as C. When that's less than 90, or then it was an acute triangle. We saw that relationship. We kind of started with the acute and then went to the relationship. So if you can take this, again, remembering how did we pick that C for the C column, it was always the longest side. And for the last one, if C squared was greater than the sum of A squared plus B squared, then the measure of angle C was greater than 90, and triangle ABC was obtuse. And again, we kind of did that little exploration in class where we gathered some data, we saw that, and that would hold true. Okay, I'm going to skip that first part. If a triangle is formed with the sides having the lengths given, is it acute, right, or obtuse? So the first thing you're going to want to do is identify the C. So this is my C side. The C is always your longest. Don't assume it's the last one. It's always the longest. Okay, so if I square 41, I get 1681. So that's my C squared. And I'm going to compare that to my A squared plus B squared. So I have 9 squared, which is 81, plus 40 squared, which is 1600. Okay, and I compare this to this. I see they're equal. So that means that this is a right triangle. Okay, so you're going to push pause and you're going to work through these, then come back and check your answers. All right, and the next one. This is my longest, so I'm going to call this C. So my C squared is 64. My A squared plus B squared is going to give me 36 plus 49. Okay. So my A squared plus B squared is here. I can see that is greater than the C squared. So since that is true, the C squared is small, then that means the angle across from it is kind of, if you think of it that way. So this is an example of an acute triangle. By the converse of the Pythagorean theorem, we can say that. It's kind of a corollary off of that. Over here, do the same thing. (49) coming from 7 squared, 64 coming from 8 squared. So that's 123. No, that doesn't sound right. 113, sorry. That's what I was going to say. So 113 to 121. The 121, or the C squared, is larger. It's going to make this one obtuse. Over here, I'm going to tell you the answer is not possible. And we'll talk in class and see if you can figure out why that is true. This one is not right. It's not acute. It's not obtuse. And let's see if you can remember why that is true. All right, over here. This one tends to be a little tricky for you guys. This is the longest. I can also figure that out because use estimation. 2 squared is 4. 3 squared is 9. So this is a number between 2 and 3. You can do it on your calculator too. And this number is a number between 3 and 4. I can see it's close to the square root of 16, which is 4. So that's my longest. When I square the square root of 14, I get 14. Okay? When I square the square root of 7, I get 7. And when I square the square root of 7, I get 7. Okay? And then that should give me a right triangle. Okay. We go over here, explain why x must equal 5. Okay, there's a couple different things you can do here. Let's see if I can do it with typing because the writing's pretty hard. I'm going to identify this right here as my longest side. So I'm going to have 8 squared plus 6 squared and I'm going to compare that to 10 squared. And again, some of you are going to see this relationship already. I gotcha. 64 plus 36. I'm going to compare that to 100. Sorry. I can see that they are equal to each other. And that means that this triangle is a right triangle. I've proven it because I proved that a squared plus b squared equals c squared. So the question is, why does this equal 5? Okay. Again, I led you to hear that I can absolutely prove this big triangle is a right triangle. And let's see if you can figure out. They are right. That's 5. Let's see if you can figure out why it is. All right, and the one down here, I know I'm so mean. I'm not telling you the answers. I'm going to use, I know the fact that this is a right triangle. I absolutely know this is a right triangle. So, because there's a right angle there, I'm going to use Pythagorean theorem to get n. And that's going to give me square root of 5 here. Because 3 squared minus 2 squared, so that'd be 9 minus 4 equals 5. That's the b squared, I guess, and then you square root it. And then over here, I'm going to test. I don't know that this is a right angle. So the square root of 5 is my longest side. So square root of 5 squared is 5. Square root of 3 squared is 3. The square root of 2 squared, which is right here, is 2. So when I take this squared plus this squared, how does that compare to that squared? They're equal. So by the converse of the Pythagorean theorem, angle D must be a right angle. Over here, very similar idea. Why must angle P be a right angle? Well, a couple different things you can do here. We can prove they're similar. I have my VAT here. 6 to 9 gives me a 2 to 3 ratio. 10 to 15 gives me a 2 to 3 ratio. So I can prove that, let's see if I can type this out for you, that triangle ROS is similar to triangle, make sure I go in the right direction, POQ by SAS similarity. Just making sure I have my corresponding parts matched up. So notice how we're bringing back things you've already learned. And this is going to happen all year. So when you get scared about the final, remember, everything keeps coming back. Then I'm going to use this. And you can use the converse of the Pythagorean theorem. I'll let you do that. This would be your C. And you will see that 9 squared plus 12 squared equals 15 squared. So I can prove by the converse that this is a right triangle, where this has to be the right angle. Well, if these are similar triangles and this is the right angle, then this is corresponding to it, so it must also be a right angle. Okay, so that's kind of an explanation there. So we'll get more into this later and talk about some uses of the converse of the Pythagorean theorem.